Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so today we're going to discuss on subtopic of 5.4 application of vectors in geometry, which is lecture 4 or 5 as you see on the screen here now. Okay, so then the objective to find the equation of straight line in the vector, parametric and Cartesian form, and determine the angle between two straight lines. Okay, so a line that passes through a point of A and parallel to the vector of V. Okay, a line that passes through the point of A, this is a point of A, and this is a point of origin of O, which is the coordinate of 0, 0 and 0. So from the point of 0, 0, 0, position vector from O to A. And a line, we call a vector that passing through the point of A and parallel to the vectors of V. So this is our reference for this particular part here. So AR is parallel to V, which is A vector of A to R parallel to the V here. So, and T is one of the scalar, and we simplify this as an equation of vector R, the vector of R from O to R equal to the vectors of O to A, which is vectors of A here, plus with the scalar of T times with the vector of V, A to R is parallel to the vectors of V. Okay, so from here, the vector equation line is equal to A, R equal to A plus T times with the vector of V. Okay. So let the coordinates of R, which is X, Y, and Z, vectors of A and V here. So we expand it, write it in the proper of vectors of R, which is X, Y, and Z, the magnitude here, equal to vectors of A plus T and the vectors of V here. Okay, so please understood the process of this from the previous page. Okay, from the picture of this. Okay, now, so by equating the coefficient of I, J, and K, okay, so X, we call coefficient of I, J, and K. So X equal to A1 plus T times V1 for I. Then you get it all here. Y and also Z. Okay, so the parametric equation of line. So this in the form of parametric equation. Okay, so what's a form in the first earlier page of this? So a vector equation of a line, which I think that this is the first one. Then vector form, parametric form. So this is the vector form, and this in the parametric form. Okay, then from here, because every single the value of X, Y, and Z here, X, Y, and Z, we got similar, which is the scalar of T. So we simplify and we come up with equation of T as you see here now, 1 and 2 here, which is all equal to the scalar of T. T equal to this one, okay, here, here, and also here. And all equal to the scalar of T. So this one we come out with a Cartesian equation of the line. Okay, now class, from this question here, just imagine that find the vector equation and parametric and Cartesian equation of a line. So just imagine that from the picture of the earliest page, this is O, okay, to the point of A, and then from O to R here. So this is R, and this line from A to the point of R here is parallel to the line of vectors of V. Okay, so in this case, the equation of the vector passing through the line, passing through the point of 1, 2, 3. So A is the coordinate of 1, -2, and 3 here. In the direction of 4 is one here, and this is considered as the vector of V, this one. So then, from equation of the vectors of R equal to A plus a scalar of T times a vector of V, then it is A equal to I minus 2J plus 3K plus T, and V is 4I plus 5J minus 6K. Okay. Now, this is vector equation in the form of a parametric. So how's the parametric then? Parametric, then we get here is xi plus yj plus zk. So in vector equation, so this is in vector equation. Now from here, x, we look at this one, I plus 4t. From x, okay, x equal to okay, so look at the one, x and then 1 here plus t, and the magnitude of I, which is 4, so 1 plus 4t, y equal to -2 minus 2 plus 5. T and z equal to, z, look at the magnitude of k here, 3 minus 6, -6 times with a t here. So this is in the parametric equation. Okay, 1, 2, 3. Okay, if I answer all this in just one page here, the parametric equation is all here, parametric equation. So then the Cartesian equation now. Cartesian equation meaning we assume that we all, okay, T is a subject here now. So then from here, T equal to, bring this one to the side. So x minus 1 divided by 4. X minus 1 divided by 4. And for y, t here, so -2 bring to the side become positive. So then y plus 2 divided by 5. And also another t here for z. Then z, bring 3 to the side become negative. So z minus 3 divided by 6. Okay, -3, z minus 3 divided by 6. Okay, so then in Cartesian equation, so then x minus 1 divided by 4 equal to y plus 2 divided by 5 equal to z minus 3 divided by negative 6. Okay, so that is a solution for question number 1. Now, so when given two lines, or we call two lines here, or called vectors of R1 and R2. So class, this is our main focus here now. The vector of V1 and V2 with a scalar of S, T and theta is the angle between them. Okay, so this is the equation of R1, equation of vector of R1 and also R2, and this angle between them. It's just like we take referring to the we call the reference vector here, which is V1 and V2, just like this one here. Okay, theta. Then, if the angle theta is angle between two straight lines of theta, then theta is also angle between V1 and V2. So, from this equation, we can straightly take this and take these two as our reference to find the angle between those two straight lines. Okay, I use the dot product of V1 dot V2 equal to modulus of V1 times the modulus of V2 cos theta. Okay, so which I think that you have seen this we call equation before in lecture 1 or lecture 2, something like that. Please refer back. We call the previous note. If parallel, so then V1 equal to K V2. Parallel means that in the same line here. Okay, or this one. Okay, look at these two here now. So before that, let's write down in the vector equation of xi plus yj plus zk equal to a1i plus a2j plus a3k plus with t and v equal to what is the equation just now? Okay, v1i plus v2j plus v3k. Okay, let's rewrite all this in this form, L1 and L2, because this in the parametric equation, a Cartesian equation. Cartesian, yes, Cartesian. We all put a T here. So then, L1, which is 5, 4, and 6 multiplied with T, and then X. Okay, so for L1, it's gonna be X, Y, and Z equal to, okay, X 5t and negative 1 bring the result become positive, so become 1, negative 2, and 0 plus, okay, the denominator of 5, 4, and t is the multiplied with the scalar of t here, so then it come up with 5, 4, and 6 t. Okay, if I rewrite all this again, it's just like xi plus yj and plus zk equal to I minus 2j plus 0k plus width t, and v is 5i plus 4j plus 6k. This is r equal to a, and this is a vector of v. Okay, so this is v1. Okay, from L1, so I name it this one as a V1. Okay, so L2 then is also X, Y, and Z. Then decimeter 3 here, negative 3, 5, and negative 1. Plus with t and v is 2, 7, and negative 1. So this is our V2. Okay. V2 is 2, 7, negative 1. So now find the acute angle between the two lines. So now, using the we call dot product, we call V1 dot V2 equal to modulus of V1 times modulus of V2 cos theta. So we're going to find out the V1 dot V2. V1 dot V2, V1 and V2 here. V1 dot V2 equal to, okay, so now it's between 5, 4, and 6 dot with 2, 7, negative 1. Okay, 5 times 2 equal to 10 plus 4 times 7 equal to 28 plus 6 times negative 1 equal to negative 6. And 10 plus 28 is 38 minus 6, 32. Okay. Then modulus of V1 equal to square root of, again, V1 here, 5 square, 25. 4 square equal to 16, and 6 square equal to 36. Equal to, equal to square root of 77. And modulus of V2 equal to square root of, now look at this one here, 2 square, 2 square equal to 4. 7 square, 49. And negative 1 square equal to 1. Then it is square root of, this one here, 54. 49, 50 plus 4, 54. Okay, so now we have found that the V1 dot V2 equal to 32, modulus of V1 and modulus of V2. So it's time for us now to find the theta. Okay, V1 dot V2, V1 dot V2 equal to modulus of V1, V2 cos theta. Okay, so this give us just now equal to 32. Okay, 32 square root of 77 and square root of 54. Okay, this is 32 equal to square root of modulus of V1. Modulus of V1 equal to square root of 77 times modulus of V2 square root of 54 cos theta. So then cos theta equal to 32 divided by these two. So then 32 divided by square root of 77 times square root of 54. Then theta equal to cos of 32 divided by square root of 77 times square root of 54. Okay, press the calculator. Okay, so you are straight to give you answers here equal to 60.2 degree. Okay. Show that L1 and L2 are perpendicular if L1 and L2 here. Okay. So for perpendicular means that it is formed at 90 degree. So our reference here right now is looking at this, which is V1 and also V2. Okay, now, so for these two lines of L1 and L2 perpendicular, for L1 perpendicular to L2, wait, this is parallel, not perpendicular. Okay, for let's say L1 and L2 are perpendicular if V1 dot V2 equal to 0. Okay, so let's find it now. This is our V1 and this is our V2. So V1 dot V2 equal to 2, negative 1, negative 1, and 1, negative 2, and 4. Okay, 2 times 1 equal to 2, plus with negative 1, negative 1 times negative 2, plus with negative 1, negative 1 multiplied with 4. 2 times 1 equal to 2, negative 1 times negative 2 equal to 2, negative 1 times 4 minus 4. Then it is equal to 0. Okay, so we come up with a conclusion that L1 and L2 are perpendicular. Okay, so we reached at the exercise, meaning we're almost at the end of the lecture for this topic, because recall for every lecture we just only discuss the solution for example, but then exercise means that we let the student try the question by yourself and see whether you can get the answer or not. So for exercise 1, okay, exercise 1, so then the answers here for vector equation, then it is R equal to A 5, negative 2, and negative 4 plus scalar of t and the vector v 3, 4, and 5. So for parametric equation, you can derive, okay, describe from here to get this one and to get another of parametric equation, which I think that is too easy. Okay. So then, and for exercise 2, okay, show that P and Q are parallel. Parallel means that, okay, parallel means that is similar direction here, and then this is for V1 and this is V2. Okay. So to see whether this is parallel or not, come up with V1 equal to K V2, where K equal to the value of lambda. Value of lambda, okay, no. Okay, just imagine that is a K or lambda is just the same. Okay, I put a K equal to -2. The answers of a K, so then these two lines P and Q are parallel. And the acute angle between Q and R, define the acute angle where theta equal to, it is 10.89 degree. Okay, so try the question by yourself. For these two exercise. Okay, so we almost meet the end of the lecture for this part here now. Okay, the vector equation, parametric, and also Cartesian equation. Okay, and again, I mentioned to all of you many times, is all the videos made by my colleague, Mr. Rodi Rajab. So, okay, you may refer to this video, and I do hope that all of you enjoyed it and understood the content of this topic of vectors. That's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.